All right, let's look at one more, like the ones that hopefully you just watched, but you don't have to watch them to understand this one. I want to know the enthalpy change for the reaction. If the enthalpy change for the reaction is this, it's an endothermic reaction, that enthalpy change, that amount of heat, is a part of the reactants. What is the delta H in kilojoules when this many grams of water react? What that tells me is in this particular reaction, again, I've got the 46.11 kilojoules. That is actually part of the reaction on the reactant side. If this had been a negative amount, it would have been on the product side. And that doesn't really matter for the equivalences. I'm wanting to relate kilojoules, though, to water. I'm trying to find out something about the water. There's my water in the reaction. So 46.11 kilojoules is equivalent to 6 moles of water in this reaction. But here's what I want to know. What is the amount of heat? What is the enthalpy change if I have 80.3 grams of water? So I know what is true for this reaction in terms of the heat and the moles of water. I want to know how that relates to 80.3 grams of water. All right. So I'm setting up my formula, I'm setting up my equation to solve, wanting to know how many kilojoules, what is the delta H in kilojoules, if I'm starting with 80.3 grams of water. And I'm going to set this up as a unit equivalence problem, or a unit conversion problems, I should say. So I'll always start with times in my ratio sign, and I'll put that unit that I'm trying to cancel on bottom, and that's going to define my path. Where am I going from here? Well, I'm at grams of water. What gets me to the equivalence in this reaction is moles of water. So the first thing I need to do is go from grams to moles. So I'll take that to moles of water using the molar mass from the periodic table. I happen to know this one. If you don't, pull out your periodic table and calculate it. It's 18.01 grams of water for every mole of water. That's 2 hydrogens and 1 oxygen. So I've got grams of water. I want to know how many kilojoules. My equivalence in this reaction is kilojoules and moles of water, so that's the path that I take. So I'm at moles of water. My next conversion factor will have moles of water in the bottom so that it cancels. And now I can use that equivalence from the reaction. I can go from moles of water to kilojoules because in this particular reaction, 6 moles of water is equivalent to 46.11 kilojoules. That's this information given in the problem. My moles of water will cancel. My answer will be in kilojoules. That's what I'm trying to find. I'm now ready to calculate. Just a quick note from years of experience. I always, am I plugging this into the calculator, I will often forget that last divided by 6. So please pay attention. So here we go. 80.3 time, you can do times 1, but you don't have to, divided by 18.01. All right, I'm on this step. Then times 46.11, then divided by 6. My final answer is, I missed it, 34.26. 264, all right, ... It looks like from the original problem, if I come back up here, 3 significant figures, 34.3, and my units are kilojoules. So my answer is 34.3 kilojoules of heat. What is the delta H? Will be the enthalpy change if I've got 80.3 grams of water. And I'm sure all of you were just screaming at your screen, water is not 18.01, it's 18.02. Just as soon as I hit the stop record, I realized it. So instead of doing the whole video, this is grams of water. Let me rewrite this, moles of water over 18.02. I said it's early. I've only had about a half a cup of coffee. It's 18.02. Now, this is a good lesson in significant figures. The only difference is that very last digit in the significant figures for the molar mass of water. It's not going to make a huge difference, But we all know sometimes our grading program is very picky. So let's see what kind of difference this makes. 80.3, I can do the times 1, but I don't have to, divided by 18.02 times 46.11 divided by 6. It is 34.245. All right, so we see the difference here. We get 34.2 kilojoules. We'd round that to 34.2 instead of 34.3. Most of the time when I set up the grading program, if you typed in this one or this one, it should take it. Sometimes I've clicked the wrong button and it's pickier. This is why I always go back and look for partial credit on these. If you've typed in 34.3 and it's counted it completely wrong, I'll probably give you full credit for that. If you're a little further off, I'll probably give you partial credit. But all it makes a difference is in that last significant figure, which there's some uncertainty there anyway. So in the world of science, when you're in a lab where you're mixing these things, it usually doesn't matter. Now, there are some professions where that might be a huge mistake. But again, this is a rule. This is how significant figures behave. All right, so the answer is 34.2 kilojoules, not 34.3 kilojoules.